Hello students, so we'll do a problem on electromagnetic theory. So it has been asked that for a plane electromagnetic wave is given as Ez is equal to A cos omega x into omega c into t, and this is the electric field in the z direction, and there is a magnetic field in the y direction, which is given as minus A sine omega x into omega ct. So we need to find out the instantaneous value of the pointing vector. This is to find it out. Now to find it out, what we have to do is the pointing vector S is E cross H, and so we do the cross product of E and Z. That means it is I j k into this component into this component. It turns out to be equal to minus 1/4 a square sine 2 omega x into sine 2 omega c t. This is the value of the pointing vector. Now the next question is to find the degree of to find out the degree of polarization. For ordinary light, reflected from glass which is having a refractive index of 1.5, and at incident angle of 45 degrees. We need to find the degree of polarization, and so we will first start with the Stan's law, that is sine theta incidence by sine theta transmittance T is equal to mu, and so here we know the angle of incident and we know mu, so we can write sine theta T as equal to sine 45 divided by 1.5, and so it turns to be equal to 1 by root 2 into 1.5, and so we take the sine inverse, this theta t, theta t is equal to sine inverse of 1 by 1.5 into root 2, and that turns out to be equal to 28.1 degrees. So then you can write the value of the refraction coefficient, that is R perpendicular, and that is equal to sine square theta I minus theta t divided by sine square theta I plus theta t. So this is actually equal to sine square 45 minus 28.1, so it has to be 16.9 degrees in the numerator, and sine square 73.1 degrees in the denominator, and turns out to be equal to 0.93392, and similarly parallel component of refraction coefficient, that is tan square theta I minus theta t divided by tan square theta I plus theta t, that's equal to tan square 16.9 divided by tan square 73.1. So the angle of the percentage of polarization P theta is equal to R perpendicular minus R parallel divided by R perpendicular plus R parallel, and if you put the values, it turns out to be 0.83268. So we can say that the degree of polarization is approximately 83.3%. Now let's move on to the next problem. In the next problem, it has been given that if the dispersion relation of a certain wave is given as omega is equal to c square k square plus m. Any relationship between omega and k is known as dispersion relationship, where omega is the angular frequency and this k, this is the wave vector. C, the speed of light, and m is a constant. M is a constant and c is the speed of light. Now, what are the properties of the group velocity? V bar, for example. So you can see that if omega is equal to c square k square plus m, we need to find out the group velocity, and that is d omega by dk. So you can write omega square is equal to c square k square plus m, and if you differentiate with respect to k, then it will be 2 omega d omega by dk is equal to 2 c square k, and it will be not there since this is a constant. So you can see that d omega by dk is equal to c square k by 2 omega. So let us write this thing once again. So again, if you write this quantity, take this quantity, so d omega by dk is equal to c square k into 2 into oh sorry, there won't be any 2 here, 2 will cancel out, so it will be c square k by omega So this will be again won't be there, only thing will be root c square k square plus m. So this is actually the proof velocity. This is d omega by dk, and we can write this in this fashion. If we take k downstairs, so it will be c square plus m square by k square. So we can see that in this case, when k tends to 0, then automatically this becomes infinity, this whole denominator infinities, and velocity tends to tends to 0. However, when k tends to infinity, this velocity v, this is now c square by c square by c square by root c square. So that turns out to equal to c. So these are the two conditions of the proof velocity. Now let's move on to the next problem. Next problem is if it's given that there is a free space parallel plate capacitor and is charged momentarily connection to voltage source. Which is then removed. Instantaneous charge. So there has to be some relationship between the energy, the displacement vector, the electric field, the capacitance, and the voltage change that is taking place. And the plates are moved apart to a separation of a distance 2d is equal to 2d1. So initially it was d1 between the plate, now it is 2d1. However, the charge has not been disturbed. So in this case, what we find is the displacement vector d is equal to simply q by a, and d2 is equal to d1. So in both these cases, the value of, since the area is the same and the charge is the same, so in both cases the displacement vector will be same, and also d is equal to epsilon 0 e. So that is why it implies that E2 will be also equal to E1. So the separation enhancement between the plates will cause no changes in D and as well as E. However, if we move on to this energy, the energy WE, this is given as equal to integration half into integration epsilon 0 E square dV, and so actually here since volume is doubled, so since d2 is equal to 2d1, so the volume is been doubled, so of course this W E dash, the new one, will be twice of WE, the old one, since this is directly proportional to the volume. Coming to the capacitance C is given as epsilon A by D1. So since the separation has been doubled, so capacitance of course will be half of the initial capacitance. And lastly, the voltage is given as Q by C. So since the capacitance has been doubled, so the new value of voltage will be twice of the old value of voltage. These are the changes.